the area under the curve seems to have something to do with the antiderivative. So why is the case? Well, what we know about power rule for differentiation is that if we differentiate a quadratic, we get a linear function. So the antiderivative of a linear function should be quadratic. And vice versa, differentiate a cubic, we get a quadratic, so the antiderivative should be a cubic. Now we haven't quite figured exactly how to get there, but we know that there's some relationship there. And I want you to kind of consider this. We have this linear function here. I want to find the area under this function. Okay, this area is a triangle. Well, I measure this triangle in squares. Should the area have something to do with the x squared function, which is where this derivative would have come from? Does the antiderivative have something to do with this area? And really, if you kind of think of this particular example, it kind of makes sense because we calculate area of triangles using squares. So the x squared function should calculate the area of that triangle. It should. Okay, and it does. Okay, we can use an antiderivative x squared sum x. We don't know exactly which x squared function gave us this one, but we could probably figure it out, and we can use that antiderivative to get connected to the area under this function. And they are connected, which then means that if we kind of extrapolate that idea, the area under this quadratic function, this area here, should reflect a cubic function, something to do with a cubic function, sorry, something to do with cubic function. Area under this, n polynomial function should relate to an n plus 1. And furthermore, these units seem to work out, because if you think of the area under this function here, this area has an x in it this way, 2x plus 1, and it has an x in it this way. And this area must have an x squared unit. This area in here, the y value has an x squared in it. I think it was 0.5 x squared in it. These units have x in it going this way. So this area must have something to do with an x cubed. Yeah, even the units work out, even the powers work out. Same thing here. If this is an xn height and an x width, this must have an xn plus 1 area. And the xn plus 1 area is the antiderivative. The x cubed area is an antiderivative. The x squared area here is an antiderivative. There is definitely something going on here. The area under the curve and the antiderivative, I don't know if this question mark, they're definitely related. There's something going on with that, and we want to really look further into that.